All right, second part of the review video, we're picking up with number 11, and we are moving on to the double angle formulas. All right, so we got three problems in one. We want to find the double angle of these functions. What we're given is a ratio for sine, which is 12 over 13, and it tells me this lies in the second quadrant. So I'm going to draw this angle in the second quadrant. Quadrant 2, that's my angle theta. And since we were given sine of theta was 12 over 13 in quadrant 2. I know that the opposite side is 12 because sine is O over H. 12 over 13. Sorry you couldn't see any of that. So I know that sine is opposite over hypotenuse, 12 over 13. Opposite side is 12. Hypotenuse is 13. The missing side of this triangle will be 5, just because we work with these a lot, and this is a Pythagorean triple that we got remembered. If you didn't remember that, we can do a squared plus b squared equals c squared, where a squared might be what we want to find. We'll let b be 12 squared, and then we'll let c, our hypotenuse, be 13 squared. A squared plus 144 equals 169. I'll subtract 144 from both sides, and I get 25. And then I need to take the square root of that, and that's how we get a equal to 5. Since I'm on the second quadrant and I'm going left, it'll be -5 for my adjacent side. Now, for the double angle formulas, I need an exact value for sine and for cosine. I was given sine. I need to write the exact value for cosine. And I know cosine is A over H. So A is -5. The hypotenuse is 13. Now I got both of the exact values I need to do the first two formulas. So let's get started with sine double angle. Okay, so from the formula, sine's double angle will be 2 times sine's exact value based on this angle times cosine's exact value of this angle. So I got 2 times sine times cosine's exact value. Simplify this and I get my answer. Sine double angle will equal, none of these are reducible, so I got 2 times 12, which is 24, times -5, which is what, -120? 2 times 12 times -5, -120, over 13 times 13, which is 169. Cosine double angle. From this formula, we'll take cosine's exact value, square it, and then we'll subtract sine's exact value squared from it. So cosine's exact value is -5 over 13. We'll square it, and then we'll subtract sine's exact value, 12 over 13, from it after we square it. Okay, so remember, when you square a fraction, you square the top and the bottom of the fraction. So what we get is -5 squared. A negative number squared is a positive number, over 13 squared, 169, minus 12 squared, 144, over 13 squared, 169 again. Since the denominators are the same, we can subtract them from one another. 25 minus 144, and we get -119 over 169. Last one is tangent. Okay, And if you recall, we can do sine over cosine. If you want to do that, go ahead and do that. I'll do the formula for this one though. Tangent's formula is 2 times tangent divided by 1 minus tangent's exact value squared. So I do need to get tangent's exact value. And here we got tangent of theta is opposite sorry, that's not the opposite. The opposite is 12 over adjacent, which is -5. Okay, so from the circle, from my triangle, I got 12 divided by -5. Let's use the formula. So we got 2 times tangent's exact value divided by 1 minus that same exact value squared. All right, so 2 times 12, 24 over -5, divided by 1 minus this exact value squared. 12 squared is 144 over -5 squared, which is positive 25. In order to subtract these two, we need a common denominator, so I'm going to convert 1 to be 25 over 25. Nothing changes with the top. I want a common denominator here so I can subtract these two. So 1 becomes 25 over 25. And now I'll be able to subtract 144 from it. So that gives me 24 divided by -5 over, and we just did this before, we got -119 divided by 25. All right, so now we got keep, change, flip. We keep the top, and we change to multiplication, and then we flip the bottom. So I can divide 25 by 5, and that becomes -1. And so now I've got 24 times 5, which equals 120. Divided by -1 times -119, which gives me positive 119. And that was my tangent. Number 12. I'm going to do this one more time. Now, if you feel like you got this on the review, you don't have to do the second one, but I did want to give more examples than just one, so you got another opportunity to practice it if you feel like you need more examples. So I'll do it again. Double angle formula for tangent, for sine, cosine, and tangent's double angle. All right, so this time we're giving cotangent of an angle equals 3. And this lies in quadrant 3. So let's try to draw that situation. I come over here, it's number 12. In quadrant 3, that's what my angle looks like. Now, we were given cotangent of theta equaled 3. Okay, so this really means 3 over 1. And now cotangent is tangent's reciprocal. So if tangent of an angle is opposite over adjacent, cotangent will be adjacent over opposite. And that helps me label this triangle. So the adjacent side is 3, the opposite side is 1. And since I'm in the third quadrant, it's -3 and it's -1. Opposite, adjacent. Let's find the hypotenuse. Hypotenuse, we got a squared, which will let be -1, plus b squared, which we let be -3, will equal my hypotenuse, c squared. -1 squared plus -3 squared equals c squared. 1 plus 9 is 10. I'll take the square root of that to figure out what just c is. And then I can't reduce this, so my hypotenuse is the square root of 10, and my hypotenuse is also positive. All right, so this is what I end up with. All right, so let's get our other ratios, and then we'll find the pieces we need. So sine of this angle is opposite over hypotenuse, and I'll leave it like that. Cosine is adjacent over hypotenuse. Tangent is just this flipped. It would be -1 over -3, so just 1 over 3. Let's do these formulas. Sine double of theta, double angle. We got 2 times sine's exact value, which we said is -1 divided by root 10, times cosine's exact value, -3 divided by root 10. I multiply the top numbers together. 2 times -1 is -2, times 3 is +6, divided by square root of 10 times the square root of 10 is just 10. So my answer is 3 over 5. Cosine double angle. I take cosine's exact value, square it, and then I'll subtract sine's exact value, squared, to get my angle, my exact value for the double angle. So -√3, so 9 over 10 minus 1 over 10 equals 8 over 10, which equals 4 over 5. Tangent, double angle, and this time let's do sine double angle divided by cosine double angle. So if we recall from what we did at the beginning, these are just the identities. So whenever we want to get tangent's value, tangent equals sine divided by cosine. Since we're doing double angle, we take the double angle values, we get the double angle exact value for tangent. So we've already done the work to get sine. We saw that sine was 3 over 5 divided by cosine's double angle, which was 4 over 5. We're going to keep the top, and then we'll change the multiplication, flip the bottom. The 5's cancel, and we've got 3 over 4. All right, number 13. 13, we got half angle formulas to finish us up. All right, so we're going to start off with the same kind of situation we were doing with the double angles. And now remember, for the half angles, we got to choose what our sign is, because these half angle formulas, we have to choose plus or minus. All right, so we're going to do all 3 with this first one. And we're given tangent of the angle theta is in an interval. And it says the interval is between pi and between 3 pi over 2. Okay, so this is 180. 3 pi over 2 is 270. So that lets us know that the whole angle will be in quadrant 3. So let's draw that real quick. I'm going to zoom in on quadrant 3. I'll draw my angle. We turned it into a right triangle. Our reference angle is here in the bottom corner. From here, we got opposite over adjacent. So we got 8 over 15. And I don't know why I made this negative. It should be positive. That's because both of these numbers are negative, and the two negatives, when you divide it, make it positive. I don't know why I copied it down as positive. It's negative. It's clearly positive here. I don't know. I guess I'm just working too fast. All right. So before we get too far, all of this information has been given to us about the whole angle. We're about to find the half angle exact values. So when we get ready to choose our sine, we need to choose our sine based on the half angle formula. And so we spent time in class talking about this, but basically an angle given to us in the third quadrant will end up in the second quadrant. Another way to do that we talked about is the half angle. We just divide everything here by 2. And when we go to the half angle, the interval for the half angle will be between theta over 2, not theta, but pi over 2. And the half angle will be less than 3 pi over 2 times 2, which is 4. So this is 90, this is 135. The half angle is in the second quadrant. So half angle in quadrant 2. And that's important when we get ready to choose our sine. Let's find the missing side of this right triangle, which is the hypotenuse. So we got -8 squared plus -15 squared equals c squared. I'll use my calculator for this one. So we got -8 squared plus -15 squared, which equals 289. I'll take the square root of that, and I get 17. The missing side is positive 17. Let's write our exact values. We will need just sine and cosine to do these formulas. And remember, I like to do this formula on the end. We just need sine and cosine. So really, that's all we need. So we got cosine of theta, given this situation, is a over h. The adjacent side is 15 over the hypotenuse, 17. And then sine of this angle is -8 over 17, opposite over hypotenuse. Let's put these into our formulas. First, we'll do sine's half angle. And remember, our half angle's in the second quadrant. In the second quadrant, sine is positive, so we'll choose the positive option. And I'll follow the formula. All right. So we got 1 minus cosine's exact value divided by 2, all in the radical. So I'm going to write my square root, my radical later. So we got 1. I just said minus, didn't I? 1 minus cosine divided by 2 in the radical. So the two negatives make it positive. And then I need 1 to have a denominator of 17. So I'll rewrite 1 to be 17 over 17 plus 15 over 17, all divided by 2 inside the radical. 17 plus 15 is 29? No. 32. 32 over 17 over 2. And remember, since this isn't a fraction, we don't have to keep change flip. We can just multiply the denominators together. So it'll be 32 over 17 times 2, which is 34. So what we get is the square root of 32 divided by 34. We can reduce both of these. They're divisible by 2. Both of them are. So 32 divided by 2 is 16 over 17 inside the radical. And then we can do the square root of 16, which is 4 over root 17. And then if I want to rationalize it, I multiply the top and the bottom by the square root of 17, and I get 4 root 17 over 17. So this is my answer. This is my simplified answer, because you can't have that radical in the denominator. Let's go on to cosines of double angle. Sorry, half angle, living in the past. Okay, from this formula, similar, except this time we got cosine plus 1 over 2. So I got to choose, should it be plus or minus? Remember, my half angle is in quadrant 2. In quadrant 2, cosine's negative, so I choose the negative outcome. And I've got cosine's exact value, which is negative 15 over 17 plus 1 divided by 2 inside. Again, I need to get that common denominator of 17. So I'll rewrite 15 over 17 plus 17 over 17. All divided by 2 inside. Negative 15 and 17 give me a difference of 2 over 17 over 2 inside, and it's negative. Don't forget about that. And then again, I will multiply the two denominators, or you can keep change flip. Don't forget it's over 1 if you do that. And what I get is negative square root of 2 over 17 times 2 is 34. All right, both of these numbers are divisible by 2. So I get negative 1 over 17. Square root of 1 is 1. So negative 1 over root 17, or I multiply the top and the bottom by the square root of 17, and I get root 17 over 17. And then let's do tangent, which is always a whole lot of fun. I'll do the formula for this one, and on the next one I will do the quotient identity. So with tangent, if we use this formula, we don't have to choose the sign. It'll work itself out. If you did this one, you would need to choose the sign, and it would be negative because the half angle is in quadrant 2. Like I say, these are 3 completely different formulas you can use. I always gravitate to this one. And we talked about it in class, but I like using this one. All right, so I got 1 minus cosine divided by sine. And these are just the exact values that we got from before. Subtracting a negative will make it positive. And I need to get a common denominator of 17. So I'll rewrite 1 as 17 over 17 plus 15 over 17 divided by negative 8 over 17. We've done this before. 15 and 17 make 32. over 17 divided by negative 8 over 17. We need to keep see, the pink's hard to see. We need to keep the top, change the multiplication, flip the bottom. 17s cancel. Our answer is 32 over negative 8. These two numbers are divisible with one another, and the answer should come out to be negative 4. All right, 3 problems in 1 there. Let's go on to number 14. And then we'll finish up with a couple of single angles with the degree measures, which are pretty straightforward. All right, so number 14, we are given secant of our angle theta has a ratio of negative 3. Now, secant is cosine's reciprocal. We know that if cosine of an angle is A over H, then secant will be H over A, because we'll flip it, right? And it tells me this angle is between pi over 2 and pi. So this is 90, and this is 180, meaning this angle is in quadrant 2. The half angle will be in quadrant 1. If we half all of these things, it tells us exactly where the angle's at. So here we multiply the denominators, we get pi over 4. Our half angle will be less than pi over 2. So our half angle will be between 45 degrees and 90 degrees. So half angle in quadrant 1. So all of these signs we choose will be positive because our half angle is in quadrant 2. The full angle, the doubled angle, or the angle itself is in quadrant 2. The half angle, half of that is in quadrant 1, which is what we're about to find the exact value of. So let's draw this second quadrant angle. We turn it into a right triangle. And we were given a hypotenuse of 3. And it's negative 3, but me knowing that the hypotenuse is positive, I'll make the 1 the negative part. And then we'll go up by whatever our value comes out to be. So to do this one, we'll do a squared plus negative 1 squared, which is b, equals my hypotenuse c, which is 3 squared. A squared will equal 1. 3 squared is 9 minus 1, which is the square root of 8 when we do both sides. And do we want to leave it as the square root of 8? Let's go ahead and simplify it. 4 times 2 is 8, so I can take out the square root of 4, which is 2, and we leave a 2 in there. So this side is 2 root 2. And it's positive because we're going up 2 root 2. All right, so we want to use that 2 root 2 because that's our exact value. Let's get our ratios we need. All we need is sine and cosine. Sine of this angle will be O over our hypotenuse. Cosine will be A over our hypotenuse. And again, notice it's secant reciprocal. Let's find sine's double angle. Sorry, half angle. Okay, and the half angle's in the first quadrant, so we're going to choose the positive outcome. And now we got the square root of 1 minus cosine over 2. Put that in the radical. Like I said, I like to draw my radical seconds when I think about it because it's never big enough. So I always go back and draw it later. So subtracting the negative, that's going to be positive. I need a common denominator to get my 1 to be with 1/3. So the 1 will be 3 over 3 plus 1 over 3, all divided by 2. 3 plus 1 equals 4 over 3 divided by 2. And then I multiply the denominators together to get it over 6. I reduce it, or actually, let's see, do I want to reduce it? How about I do the square root of 4 is 2 over root 6. And we can leave it as that, or we rationalize it, and we should get 2. We end up having to reduce it anyway. So we get 2 root 6 over 6, which will reduce to root 6 over 6 divided by 2 is 3. So this is my answer. This is my simplified answer. Let's go to cosine. Okay, in the first quadrant, so we choose the positive outcome. This time we got cosine's exact value plus 1 over 2. Need a common denominator for 1. So 1 will be 3 over 3, so plus 3 over 3 divided by 2 inside. Negative 1 plus 3 is 2 over 3, but let's go ahead and multiply the denominators together, so it'll be 2 over 6 inside the radical. And just to be clear, we had 2 over 3 all divided by 2. Went on and just did 3 times 2, which gave us a denominator of 6. So basically what I did was combine these two, and then I keep, change, flip, if that's what you want to think about. But I did this step right here, and I just went on and applied it. And this we can actually go ahead and reduce now. It gets me 1 over 6 inside the radical. The square root of 1 is 1 over root 6. And then if I multiply the top and the bottom by root 6, this is my completely simplified answer. Now for tangent, let's do quotient identity. And you could do the formula. You can also do this if you know what sine and what cosine are. So we got sine was root 6 over 3 divided by cosine, which we got as root 6 over 6. We'll keep the top, change the multiplication, flip the bottom, and we get that. I can divide both of these by 3, and we get, oh, and the root 6's cancel as well, which leaves us with the answer of just 2. Oh, I just caught a mistake, guys. So down here, this should be 3 because we reduced both of these by 3. So when I get here, this will be the square root of 3, and my answer should come out to be, if I rationalize it, root 3 over 3. Right, so let me make a change here. That was cosine, so I need to change this one. So it would be root 3 over 3. Then I'll go and change this over here, or actually let me just scribble this one out. And what jumped out at me was like, these two should just cancel out to be the same. And that just, it didn't feel right. That made me like go and check my work. Because like I say, repetition is how you get better at math, honestly, just like with any other thing. And I knew through repetition that these two normally cancel out, so it made me kind of backtrack and see what wasn't right. So when we keep change flip, we got root 6 over 3 times. So we change the multiplication and we flip the bottom one to get it over root 3. The 3's cancel. And what happens here is we get root 6 over root 3. And since they're both under the root, I'll add a step and show you that we can think about it like this, which comes out to equal 2. And the square root of 2 is my answer. All right, and then we got a couple more half angles where it's just the angles, and we're just finding one of them, so maybe go a little bit quicker. Number 15, we got cosine 22.5. All right, this angle is in quadrant 1, so it's going to be positive. We need to double it, and we get 45 degrees. So that's what we'll put into the formula. So going to cosine half angle formula, we'll do cosine of 45 over 2. That's just how the formula looks. And now I'll do that cosine formula for the half angle. We're in quadrant 1, so we're going to choose the positive option. And I've got cosine's exact value at 45 degrees. I'll write this first one. Plus 1 divided by 2 inside. Cosine of 45 is 2 over 2 plus 1 over 2. I need a common denominator of 2. So 2 over 2 plus 2 divided by 2 all over 2. So I can't put these twos I can't do the root square root of 2 plus 2, but I can write them as like a single fraction. So I'll do that. And this is all divided by 2. All divided by 2. Now, like we were doing before, I take the denominators, multiply them together. 2 times 2 is 4. And then the square root of 4 is 2. So I can take that 4 out to get my answer. Next one, we got cosine of 11 pi over 12. Well, 11 pi over 12, where is that at? I might compare it to pi. Because if I multiply pi by 12 over 12, I get 12 pi over 12. And then if I compare 11 pi over 12 to that, I see that pi is a little bit bigger, meaning this angle is in quadrant 2. Since I'm doing cosine, I'm going to choose the negative option because cosine is negative in quadrant 2. All right, so now I'll take my angle and double it. That gives me 22 pi over 12. And I'll divide the top and the bottom by 2, and I get 11 pi over 6, which is 330. So this angle will be in the 4th quadrant. So cosine of 11 pi over 6 divided by 2, because we're doing the half angle. That's how the formula looks. And now my half angle is in the 2nd quadrant. We said it would be a negative option here. And then we'll do the formula for cosine. So we got cosine of 11 pi over 6 plus 1 divided by 2. Cosine of this 30 is positive 3 over 2. Let's go ahead and rewrite 1 to have the same denominator. So it'll be plus 2 over 2, all divided by 2 in the radical, and then this is the negative 1. I put them together. And it's going to be 2 over 2, which will come out to be 4. The square root of 4 is 2, so my answer comes out to be negative square root of 3 plus 2, all divided by 2, because the square root of 4 is 2, so we were able to take that out. All right, and tangent. Well, pi over 8 is smaller than pi over 6, so this angle has to be in quadrant 1, so I know it's going to be positive when I choose from the half angle. Let's double this angle. Pi over 8 times 2 equals pi over 4. So this is tangent over 45. So I've got tangent pi over 4 divided by 2 to set up my half angle formula. So what we'll have is 1 minus cosine of 45 divided by sine of 45. 1 minus cosine of 45 is 2 over 2. Sine of 45 is also 2 over 2. Common denominator of 2. And I'll go ahead and put them together. So minus root 2. So just to be clear, that's my 1. That's what I had, square root of 2 over 2. I put them together since they both had a common denominator of 2. This is divided by root 2 over 2. This time I need to do some keep, change, flipping. So I keep the top. I'll change the multiplication and I'll flip the bottom. The 2's cancel. What I'm left with is 2 minus root 2 over root 2. That's my answer. I shouldn't leave it like that. So let's do some simplifying. What I would do is multiply the top and the bottom by the square root of 2. And now on the bottom, the square root of 2 times the square root of 2 is just 2. And I need to distribute this on the top. So on the top, I get 2 times root 2 minus root 2 times root 2, which is just 2. It's a lot of 2's. In fact, they cancel. And I'm left with root 2 minus 1 as my answer. Last problem. Tangent of 105. All right, 105 is greater than 90. So 105 is in quadrant 2, and meaning tangent of the half angle is negative, because tangent is negative in the second quadrant. But actually for tangent, I don't even have to decide. I forgot about that. We don't have to decide because it'll work itself out. All right, so let me double 105. Should equal 210. And 210 is on my unit circle. 210 right here. Now, 210 is in the third quadrant, so that's why I say make sure you always ask yourself, where's the original angle? Where's the half angle at? Second quadrant, it should come out to be negative. So we got tangent of 210 over 2. Using my half angle formula for tangent, I got 1 minus cosine of 210 divided by sine of 210. That's 1 minus, 210 is a 30, it's 30 away from the x-axis. So I know cosine of a 30 is 3 over 2. And in the third quadrant, it'll be negative. And then sine of a 30 is 1/2. In the third quadrant, it will also be negative. On the top, a negative minus a negative will make it positive. And then I need 1 to have a common denominator of 2. So I'll write it as 2 over 2. And then what we already had was plus root 3 over 2 also. And then this all is divided by negative 1/2. I'll keep the top. I'll change the multiplication and I'll flip the bottom. The 2's cancel. And I'm left with just negative 1 in the denominator, which basically means we will change the signs. So it'll be negative 2 minus root 3. All right, and that is the review. So like I say, maybe pick a few problems from each section. If you feel pretty good about them, don't be so stressed out about, I gotta finish the whole study guide. It's more important that you're able to work the problems from the study guide than just have all the study guide answers written down. Let me know if something doesn't look right. I did kind of rush through this, so if you think something's a mistake, just mention it to me. It probably is. Good luck. See you guys.